Welcome to Purdycast1. My name is Mr. Purdy, and I am a 6th grade math teacher at the Dr. George F. Mack Middle School. Today's topic that I'm going to discuss is on classifying rational numbers. And to start us off, we have to first define what a rational number is. A rational number is any number that can be expressed as a fraction. And the form that we're going to use is the form a divided by b, where both a and b are integers, and b is not allowed to be equal to 0. In our fraction, the letter a is used to represent the numerator, and the letter b is used to represent the denominator. And the most important thing about a fraction is both a and b again have to be integers, but the denominator is not allowed to be equal to 0 because division by 0 is an undefined operation. So to get back to the topic of rational numbers, we're going to use a diagram today called a nested Venn diagram. To describe and look at the subsets of the rational numbers. So I've drawn this large circle to represent the whole set of rational numbers. Now, within that set of rational numbers are two sets of numbers: the set of integers and the set of whole numbers. And to look at those two sets, we're going to look at a number line. Now, on a number line, the whole numbers are any numbers that are 0, 1, 2, 3, 4, 5, and so on. And all of these numbers are on any hash mark on the number line. And there's an infinite number of whole numbers as they continue on forever. Now, the set of integers are all of the whole numbers as well as their opposites. And if you look at the diagram above, the whole numbers are within the set of integers because they're called a subset, and then the integers are a subset of the rational numbers. So let's look at a couple examples. The first number we're going to look at is the number -10. We're also going to look at the number 0.15, the number 4 2/3, and then finally we'll look at the number 72. So the first thing that we have to do is we have to classify each of these numbers and determine whether or not they are rational numbers. So first, let's note a couple things. -10 is an integer, since it can be graphed on the number line, and it falls at -10. And the number 72 is a whole number. And it can also be graphed on the number line at one of the hash marks at +72. Both of these numbers are integers. The difference between them is that 72 is a positive integer, which makes it a whole number. Our other two examples, 0.15 and 4 2/3, are not integers. Now, to determine whether each of these is a rational number, we have to be able to express each as a fraction. The decimal 0.15 can be read as 15 1/100ths, or 15 over 100. 15 over 100 is a fraction. Both the numerator and the denominator are integers, and in this case our denominator of 100 is a non-zero integer. So the decimal 0.15 is a rational number. Our other example is what we call a mixed number. It's a mixed number because it has a fractional part, 2/3, as well as a whole part of 4. Now, a mixed number is a fraction, but to determine whether it's a rational number, we need it in the form a divided by b. And to convert mixed numbers into this form, we have to convert it to an improper fraction. And the way we do that is by taking the denominator of this fraction and multiplying it by the whole part, and then adding to that the numerator. So what we end up with is we have 3 times 4. That result is added to 1, and then we place this entire thing over our original denominator of 3. And if we simplify this, 3 times 4 gives us 12. 12 plus 1 gives us 13. And now we have the fraction 13 over 3, which is of the form a over b. So all four of our examples are considered rational numbers. And now we're going to classify them and place them in the correct subsets of the rational numbers. So I'm going to begin by drawing the large circle to represent the rational numbers. And then again, within the set of rational numbers, we have the set of integers. And then within that set, we have the set of whole numbers. So, our first example of -10 is an integer, so we're going to place it in our integer circle. The decimal 0.15 we did express as a fraction, and it's the fraction 15 over 100. The reason that we wrote that as a fraction is to justify that it is a rational number. But the decimal 0.15 is neither a whole number nor an integer, since it can be not graphed on a number line at one of the hash marks. So we're going to place it in the outer circle of rational numbers. The next example of 4 2/3 again is neither an integer nor a whole number and will be placed in the outer circle with rational numbers. Our final example of 72 is an integer, but more specifically it's a positive integer, and 72 is classified as a